Hi folks, welcome back to 7.1 part 3. And so in this video, we're going to take a look at verifying trig identities, okay? Now, admittedly, this is one of my favorite things to do mathematically because I feel like it's really satisfying. And I know that it does not bring the same joy to other folks, okay? But it is one of those things that I think if you can conquer this beast, so to speak, then in a lot of ways you've really learned what it means to be a mathematician and really just kind of think about how to argue things in a way that's logical, right? And so even if you never use things again with trig, I think it's useful in your real life to think about like how you might be able to convince someone that something is actually true, okay? All right, so a little definition for you here. Verify. We are not in law right now, so it does not mean to swear or support a statement by affidavit, but rather we want to make sure or demonstrate that something is true, accurate, or justified, okay? Now, we're going to start off with a little bit of a conceptual understanding. Like, what does it mean to verify? Okay. The short answer is we're really trying to show that for whatever equation we have, that whatever we have on the left side is actually exactly like what's on the right side. Okay, so we want to show that these two sides of the equal sign are actually equal to each other. And so we're going to start off by doing this graphically. Okay, before we jump into all the algebra, which again, I love, and I know I can be a little bit of a nerd like that. I just want to show you in a picture what it means to be verified. Okay, so we're going to change screens. We're going to go to Desmos. And I'm going to show you a little bit on how to use Desmos because I think it's useful in case you don't know how to do it. And what I'm going to be doing, I'm going to graph cotangent theta. And then separately, I'm going to graph 1 over tangent theta, okay? Now, we know that this is true because this is one of the reciprocal identities, okay? So I've told you that this is true, but now I'm going to show you that it's actually true, okay? So I'm going to go ahead and change screens. Go to Desmos. And I'm going to type in a function. So the first thing I'm going to type in is cotangent. But I don't need to use the keyboard. I can actually just go over to the button where it says functions and push that. And I see the COT, cotangent, and I'm just going to use X. I don't need to use theta, okay? Now this is what the graph of cotangent looks like. And now I'm going to hit enter. And this is going to bring me to a second graph. And now I'm going to type in 1 over tangent. So 1 divided by, go back to functions, tangent x. All right. Now, we've got the blue graph and the red graph. Blue and red. They're exactly the same graph. That means that cotangent theta is actually equal to 1 over tangent theta. Okay. Now, the second example, or example 6, I'll read it to you just so I don't have to switch screens again. It says tangent theta cosine theta equals sine theta. So we're going to go to our functions, tangent x, close it, functions, cosine x, close it. So this green squiggly wave is what tangent x cosine x looks like. I'm going to hit the blue button. It's going to make me go be able to type in a second function. And on this one, I'm going to type in sine theta or sine x. I'm going to go back to functions, sine x, close it. All right. So we have a purple graph, green graph, purple graph, green graph. They are exactly the same. That means that tangent x cosine x is equal to sine x. And that's how we verify it graphically, okay? So no matter how crazy the equations are that we're working with, one thing to keep in mind is that if you graph both sides, they sure should look the same, okay? That's really what we're trying to prove. So we've graphed these two, we have verified them. Let's move on to what it means to verify algebraically. And in fact, with example 7, you'll notice we have the exact same example that we did before. All right, this is exactly example 6. But now I want us to do it without using Desmos to show that the two sides are the same. I actually just want us to go ahead and use the identities we've learned to verify. All right, so a general strategy here, and this is important that we listen up. A general strategy here is that we're going to go ahead and choose the more complicated looking side. We're going to take the complicated looking side. We're just going to say, yep, we're going to start with the harder part, and then we're going to go ahead and use our identities and try and get back to the simpler side, okay? So one thing, when we're writing this, we always need to write both sides, all right? So whatever your work is that you turn on the quizzes and the homeworks and the exams should look like what I'm writing here, okay? All right, so let's get started. Tangent and cosine, all right? Tangent, I can write as sine theta over cosine theta. And I know I can write it this way because of our quotient identity. Cosine theta is already in cosine, so I'm going to do times cosine theta over 1. Now I have to write equal sine theta. You have to write this part. Unless you don't want full credit, then you don't need to write it, okay? But if you don't have that there, it's not full credit. All right, cosine theta. I put it over 1 because I knew I was already working with a fraction. And so now I can see that this cosine in the numerator and this cosine in the denominator, well, they reduce to 1. So all I'm left with is sine theta equals sine theta. Give yourself a check mark because that is correct. But we do want to annotate here that we are using algebra to get to that step, okay? So a few things I just really want to make sure we're all listening here. You gotta annotate. You don't have to use a different color, but you do have to annotate. And you gotta write both sides. You have to write both sides. All right. Okay. Let's take a look at example 8. So example 8 says cosecant theta cosine theta times tangent theta equals 1. Well, I think we would all agree that this is the more complicated side. So let's go ahead and start with that. All right. Now we're going to use that trick. Let's turn everything into sine and cosine and see what happens. All right. Let me do some color coding to help us out. Cosecant, cosine, tangent. All right. Now I bet we're going to have some fractions. So even though cosine's already cosine, I'm just going to leave it as cosine over 1. Okay. So let's start with cosecant. Cosecant is 1 over sine theta. Cosine, I'm going to leave as cosine theta over 1. And tangent theta, I'm going to write as sine theta over cosine theta equals 1. All right. So I've got cosine theta here. I've got what used to be tangent here. But this so far is still not full credit. I need to make sure I annotate. This is my reciprocal. And this is my quotient. Okay. So reciprocal and quotient. All right. Let's see if we can do any algebra now. Looks like we got cosine and cosine that reduce. Looks like we got sine and sine that reduce. Wow. We're only left with 1 over 1. And 1 over 1 is, you guessed it, 1 equals 1. And the step we have used here, we could just say is algebra, but yes, we have verified that this identity is true, okay? All right, so these are some of the more simple examples, all right? But before we dive into the more juicy ones, let's take a look at this general guideline, okay? Now, this is straight from your textbook, and I just wanted to remind you, like, yes, we have a textbook, and sometimes when we're having trouble, we go straight to like a video or something, which is fine, but sometimes it's important to have these steps written down. Like, this might be a great thing to put on a reference sheet, right? What better to just tell you steps on what you should try first and second and third and fourth, rather than just having only one example that might not look like what we have on the test, okay? All right, so we're going to do a few of these examples together, and I may leave the rest of those for practice for you, all right? But if they're practice ones, you are more than welcome to come in and check with me during office hours to see, what the answers are. All right, let's take a look at example number 9. Now, this looks pretty gross, all right? But sometimes I actually like to start with the algebra, and sometimes I like to start with my trig identities. So it really depends. Okay. Now, I think one trick we've been using is let's turn everything into sine and cosine. All right. So let's kind of try that and see. All right. So I've got sine squared theta over 1 times, let's see, secant is 1 over cosine squared theta plus sine squared theta over 1 times cosecant is 1 over sine squared theta equals, write that other side. Okay, now if the color coding is helpful for you, right, we might want to do this and this and this and this, just to kind of keep track of what's going where. All right. Now, some people just kind of write all the algebra and then they get really fussy about having to go back and put in the trig identities, like the annotations. I encourage you to do it while you're going. Okay. So right here, I might say this is the reciprocal. This is also the reciprocal. All right. So get that down there before you get too far in. All right, now let's see if we can do any algebra here. Well, sine and sine, those reduce. Oh, I've been doing that in red. Let's continue in red. Sine and sine reduce. All right, but what do we have over here? Sine squared over cosine squared, that actually turns into tangent squared. Plus 1 equals secant squared theta. Okay, so I've used some algebra here, but what I've used here is the quotient identity. All right, so algebra and the quotient identity. Now, we have one last step. Tangent squared theta plus 1, that is secant squared theta according to our Pythagorean identity. So we get secant squared equals secant squared. We're good to go. But to get full credit, we want to say this is the Pythagorean identity. Okay, so we've got this big, long, ugly thing, and we've shown that both sides are indeed equal to each other. Okay, all right, let's do one more example before we move on to the next video. Okay, all right, let's take a look at example 10. So which side do we think is the more complicated side? Well, I think this side is probably a little bit more complicated. So I'm going to start with the left-hand side. And I'm actually going to do some algebra first here, okay? So I have tangent theta over 1, and I'm going to multiply it. Instead of dividing by secant, I'm going to multiply by the reciprocal, which is 1 over secant theta equals sine theta. Okay, so this tangent is here, and this secant is here. And now, because I'm trying to go to sines, I'm going to try and turn everything into sine and cosine and see what happens. So tangent is really sine theta over cosine theta. So let's color code that in the pink. Times secant theta is really cosine theta over 1. And we'll highlight that in the green. And we're going to write the other side because we do want full credit. All right. Now, let's pause for a moment and annotate a little bit. Okay. So in this step, I think we've just done some algebra, but we would call this the quotient identity, and we would call this the reciprocal identity. Okay. All right. Now, I think it's time for some algebra again. And some of us might be like, wow, we're super close to being done because cosine and cosine reduce to 1. And I'm left with sine theta equals sine theta. All right. And we would just annotate this last step as algebra. All right. So as promised, we're going to stop here. Come on back for the next video so we can do more examples together.